we would like to plot our simulated results from Comsol and calculated results from the analytical equation on the same graph. We want to overlay the Comsol quote-unquote data and our analytical calculation. So for Fresnel equations, I'm showing one example here. This is the reflection amplitude coefficient defined in Mathematica as a function of angle of incidence, theta I here, and the ratio of the transmission refractive index divided by incident medium refractive index, NIT. So this is one of the expressions for the reflection amplitude coefficient for S polarization, for polarization perpendicular to the plane of incidence or transverse electric. Now, since we are plotting reflectance, I'm defining reflectance. Here I'm using Ni and Nt, incident medium refractive index, transmission medium refractive index, and Nt over Ni is expressly shown here, and I'm taking its square. So from Comsol, we can learn the refractive indices at 600 nanometers. That's the wavelength at which we did the simulations. So let me show you how you do that. So you go to Comsol. As you see, parameter is 600 nanometers. Under the material, if you expand, you will see refractive index node. And the real part of refractive index is what we need. When you open it, it is interpolated based on data. So the data is given here. And you can get this plotted. That's fine. This is the plot. And it starts from around 200 nanometers. So you need this first part. So you can, if you like, zoom into that area. So 600 nanometers is about here. As you see, it's between 1.455 and 1.46. If you like, you can further zoom in that area. Here's a 600 nanometers. It is 1.458. That's what you see. Or in the data, we have a data point at nearly 600 nanometers, 599.4. Again, it shows 1.45806. So, I mean, that's how you get the refractive index you need to use in your analytical calculation. I got that, 1.45806, and air refractive index is taken as 1. So, and then in this plot theory, I'm naming the plot as the plot ref theory. I'm plotting from 0 to 90 degrees, pi over 2, and reflectance for air and fused silica at 600 nanometers. And this is what I have. I mean, by itself, as you see, this shows very similar to what we learned, what we showed in Comsol simulation. Okay, let me go to Comsol simulation. I mean, first I want to export the data. So I go here, results. The 1D plot group shows this. So I'm looking at the reflectance, the blue curve. That's what I need to transfer. Okay. And what I do here is I select my plot data here, right click. There are multiple options here. You can say copy plot data to clipboard and then paste into something like Excel. Or you can export it and then import into a file, basically. you can copy plot data to a table. Okay, we can try each of those. So let me go to export, add plot data to export. Again, it says it showed here. And then we will select file type, and plot group is given. Okay, and the plot is given the global calculation here. And I want the text file, and then I want to select my file name. Let me put it on desktop here. And that's going to be, say, data RS, okay, for reflectance, for S polarization. And I want CSV file, comma separated values, and save. Data format spreadsheet. If I have multiple curves, I want to add them as columns. And I say export. When I export it, it should give me the file in the desktop in this case. So let's verify that. Okay, I'm looking at desktop, and indeed, that's where I have data rs.txt.csv. Let's open it with Microsoft Excel. Here's my data. So I don't need the, for my particular comparison, I don't need the transmittance data. So I only need angle of incidence and the reflectance. Okay, so this is angle of incidence, this is reflectance. So let's select those. So I don't need the others, so I'm going to just delete them for this particular case rather than selecting them, okay? So I will go ahead and delete. And then I'm going to get rid of this last column as well, delete. Okay, so now I'll save it. Okay, so now this you can import into Mathematica. So in Mathematica, I can use the import command to import the data. You need this kind of a syntax. I'm naming the data as data rs equals import, and then between quotation marks, you enter the location and the file name. To get the location on a Mac, you can select the file command I, and then you can see the location here. You can copy and paste this into Mathematica, okay? And once we do that, the data is imported into Mathematica as a table. So this is the data. One other way you can achieve the same thing, so let me use another name for it. You can write data rs equal 1 equals, and then you can take your file and drag and drop here. And that way you can directly drop the data here. It will read it and then properly import into Mathematica. Okay, so I have both of them, but important thing here is, okay, let's remember I have the theoretical plot here, and I'm going to go down. Now I have the data, so I'm going to do another plot. Let's call it plot data equals, and then I will do list plot of data rs. Indeed, that's the data from Comsol. Now I want to join these two together. So I have plot data, and then I have plot ref theory. Those are the names. I'm going to combine them. You combine them using the show command. So here's what you need. I'm just pasting because I have prepared this ahead of time. So plot data, one of them, plot ref theory. I'm putting a frame and then labels for it. Let's do it. And indeed it happens. So data points are shown and the analytical plot is also shown together on the same graph.